Yo, what's going on, guys? It's Elijah here, and in today's video, we're going to be analyzing not one, but two tornadoes that touched down in Ohio, specifically possible twin tornadoes. And when I say possible, it's because the National Weather Service does not actually know if they were twins or not, but they did say an answer to the question of are they twins, and we will see that at the end of the video. So let's dive right on in. So, the two towns in question are Versailles, Ohio, and Russia, Ohio. And so we're going to just start out zooming out. For this analysis, I'm using the Dayton radar, TDAY, and we're going to be using short range reflectivity mixed with base velocity, because that's the two radars that this radar specifically has. And I'm also on radar Omega. So, this I have it preloaded for about 3 hours. We're going to start at around 2:30 a.m. on March 6, 2022, and I'm just going to let it run, and you guys can see if you can spot the tornadoes. They're in this area. I'll just kind of point you to that area. They would be in this area, okay? So let's see if you can spot them. So, yep, right there's the storms coming through. There's the storms hitting the area, and the storms have passed. Did you spot the tornado? Probably not. So let's actually go into this area and look at these specifically. So I'm going to go ahead and back up, so we're going to just look through it kind of on the scroll bar here. So currently it's 2:30 a.m., not really much going on. We keep going, okay. Here's the storm starting to come into range. 3 a.m.-ish, they're starting to come into the area. All right, 3 here, I'm going to just go slow so you can see it. You might think that's a hook. Could be. Up, they're hitting Versailles. Alright, then it keeps on going through. Up, it's hitting Russia. Alright, then we keep on going through. Up, next wave is hitting Versailles. Then we keep on going through. Up, next wave is hitting Russia. And it keeps on going. And by 3:26, both towns are out of the area. Now, what if I told you there was two tornadoes in there? And you might say, I didn't see any hook echoes. Where were these tornadoes? I'm about to show you. But let's just say this, the National Weather Service confirmed two tornadoes here, one north of Versailles, one north of Russia. So let's actually kind of look at them specifically. So, if I zoom in a little bit, you're still not going to be able to see much on the short range reflectivity. But you can see a little bit. I'll try to point you to the area of them. And then we'll look at the velocity here in a second. So, the first tornado touched down at 3:21. So this is 3:20. This is actually before either of the tornadoes touched down, okay? You can't see much. Then we go to the next scan, 3:21. At this time, the National Weather Service does not give seconds, so this is 3:21:41. So there is a chance the tornado is on the ground. It would be right here. That is the first tornado. That is a very weak rotation, I will say that, but that right there would be the tornado. And that also will match the damage survey, which you will see at the end. So we keep on going. Oh, I skipped too much. So that's 3:21. Then we go 3:23. Uh-oh. Here's the key thing. There's a chance that both tornadoes are on the ground at this time. I'm going full screen for this. Can you see both tornadoes? Probably not. So I'll kind of try to point you to the right area. This area right here is one of the tornadoes. I don't actually have it memorized, so I'm not sure if it's that or that is the tornado. And the other tornado is right here. Yeah, very confusing, but that's a tornado, and either that or that is the other tornado. That's the first two tornadoes. They're both on the ground in this scan. So then I'm going to go out of full screen so I can see the exact time stamps. Then 3:24. This tornado here is where I'm assuming by this scan has actually dissipated. They said the survey went till 3:24, but if you look here, you can't really see anything, so I'm assuming from this specific scan, the first tornado has already lifted. This tornado, however, is still on the ground, and it is right in this area. Then we go to 3:26 here, because there's no scan on 3:25, and both tornadoes have lifted. Yeah, crazy. That has, like, nothing. That is very weak. If you were to look at that, like, even just looking at the reflectivity, you could not tell that a tornado was there. Some people might think there's a tornado there. I actually asked a few other radar analysis people to see. Some people thought it was there. Some people thought it was there. So let's actually switch on over to the velocity now. I gotta go out of full screen here. And so the velocity, we're going to use this radar here on the left. Now, the velocity is going to be a little bit whack at first, just because this is an airport radar. It's not like an NWS radar, so it's going to pick up a lot of just interference before the storm gets here, as you can see right there. But once the storm comes through, as you will see here in just a second right there, ignore the reflectivity on the other side. They're off-synced, as you can see. Velocity is at 309. The reflectivity is at 316, so just ignore that part. Let me actually go out of this. I can then switch that so it's just going to be the velocity. So that will be a little better for everyone to see. All right, so to get toward the area, as you can see here, here's the thing. Actually, I apologize for this. I am going to go split screen, but I'm going to keep it on velocity, both of them. So it's easier so you can see the time at the top. That'll be the best situation. All right, up, and I have to preload the thing in. That takes just a second here. I already have it preloaded into the radar history, so I can easily switch back in case this problem happened. I anticipated that problem in advance. All right, so here we go. So 3:14, as you can see, the storms are starting to enter the area. 3:15, they're still starting to enter. You might say, ooh, that's got some stuff going on, but you would be wrong. That is actually not the location of it yet. As you can see, 3:16 hitting it, 3:17, it's already past Versailles. Tornado hasn't been spotted yet. You might be thinking, that's the tornado. That is actually velocity before the tornado touched down. If you look at the timestamp 3:20, this is a minute before it touched down. The tornado will touch down right in this area. That is the velocity before the touchdown. And as to show that it was not there previously, right there is the scan previously in that entire area near Versailles, and it is not there. So we're going to go to 3:21. Oh, I skipped too far. Right there. Oh, there was no, I forgot, there was no velocity scan until 3:23, which is when both tornadoes are on the ground, and it is kind of clear here. So right there is one tornado. It's weakening. As you can see, it's kind of just a hole, but if you click at the miles per hour, you can see kind of 33s. You might get, I think yeah, there was some 40s right there, negative 46. So it is still there, but it's very weak around the area. There's a negative 49. But over here, this is the main show. This is the other tornado. As you can see, they're both right there. These are from the both same cell. This is the same storm. Right in this area is the same storm still. So they would be twins. If these were on the ground at the same time, these are twins. But look at that. 82 miles per hour. Negative 24 right next to it. Negative 22 on the other side. But that 82, there's a 51 right there, but that 82.77 miles per hour is a very key thing. That kind of shows the rotation right there. You can clearly see the rotation right there for the second tornado. Then we're going to go, and I'm not sure when the next velocity was. It was 3:24. So you can see a little bit of rotation still in this area. Most likely the other tornado is still on the ground. The first tornado has dissipated at this time, unless that right there is it, but I do not believe that was it. I believe the other tornado dissipated up near 47, so I'm pretty sure it has dissipated according to the velocity at this time. The second one, however, is still ongoing, and it is right here, I believe. It's difficult to tell exactly. I will overlay the damage survey at the end so you can see it. I'm just doing a radar analysis to start with. And then we move into the next step right there, which is 3:25. Tornado has either dissipated or is in the process of dissipating in this area, as the survey says it ended 3:25. Unfortunately, the National Weather Service does not go down to the second, so we do not know if it has dissipated at this time, or if it's like still ongoing and dissipating within seconds from this sweep. So, yeah, that's basically it. We do not have any more of the scans. As you can see, this is the only products from this specific radar. Unlike a National Weather Service radar, we do not have like a CC scan from this, a correlation coefficient scan from this. We do not have any other scans from this because this is a smaller radar, and we're actually using a small reflectivity. As you can see, like, this is the range of a normal NWS radar. As you can see, it just butchers. It just goes crazy after a certain distance, and that's because it's not rated for those. If you look at like the Wilmington radar here, this is a National Weather Service radar, National Weather Service of Wilmington, Ohio. As you can see, when I click this one, there's a lot more there, and when you click up here to see how many scans, there is a lot more scans available. So you can only see the rotation on this specific radar specifically, which is why I'm doing the scan. That is also the reason both of these tornadoes were unwarned. Both of those tornadoes, the one north of Versailles and the one north of Russia, were both unwarned tornadoes. So that is why there is a decent chance, according to the National Weather Service, I guess, that, in a way, these were unwarned twin tornadoes. That is insane that we had unwarned twin tornadoes. I mean, granted, there was no clear way for the National Weather Service to pick it up, as I will show right here. If we go to I will actually just show that real quick so people understand why they did not warn the tornadoes. You saw the rotation based on that radar. If we go to the radar down here, which this is the closest National Weather Service radar, if we go back to Versailles, I lost track of Versailles. 1 second. Versailles right here. So right here, if we go right here, I'm going to I think I have it already preloaded. Yes, I do. Okay, so just to show, I will switch. This is the high-res reflectivity right as the storms came through. You can see a little bit of like a small thing forming right there. However, it kind of just vanishes right there. You could maybe see the glimpse of the first tornado right there. Maybe. There's the scan at 322. You could maybe see the first tornado still on the ground. The second one hasn't touched down yet. The second one, you can't even see it. It's just all jumbled together, and it's gone. So, and then just to show proof that they really had no visual of it, I already looked at this, but I did not see velocity difference at all when I was going through it. So, these scans are pretty much aligned in a way. They're a few minutes off, but not bad. So, just to show, if you look at the reflectivity here, 320, there was a scan. Of course, it does not show any of the reflectivity in this area, even though you saw the other one. This is 323. Both tornadoes are on the ground at this exact moment, according to the other velocity. And as you can see, there is nothing. You can't tell that there was tornadoes there, according to the velocity from the National Weather Service radar. That you could not tell that there was tornadoes, because that's not the tornado. The tornado would have started right here, as you'll see here in just a second. The tornado started right over in this area and moved that way. There is nothing. So neither tornado showed up according to the National Weather Service radar, but they did show up according to the Dayton radar up here. So that's just something right there. I think the National Weather Service did an amazing job still, even though they did not warn those tornadoes. As you could just see, they had no way to tell that those were warned. So let's go ahead and see what the National Weather Service said. Alright, so in a tweet to the National Weather Service, I actually asked them this question. I have a question. So the damage surveys show an overlap where both of the tornadoes in Darke County were on the ground, that's OTG, on the ground at the same time. When I checked the radar, they appear to have been from the same cell. Were they twin tornadoes for a minute? The National Weather Service of Wilmington, Ohio replied, yes. It appears that one tornado formed around the same time as the other was dissipating. They may have briefly been on the ground at the same time, which if they were would imply twin tornadoes. So, that they do not confirm twin tornadoes, but they do confirm one thing. They confirm that it appears one was dissipating as the other was forming, so if at any point in time they were both on the ground at the same time, they were twin tornadoes. And there is your analysis over the two unwarned, possibly twin tornadoes in Ohio on March 6, 2022.